All right, so I just went through how to derive the Pythagorean identities, and I'm ready to start my three-part series on how to verify a bunch of trig identities. In each of these three videos, I'll do three verifications. And in this first one, I'm actually going to start off with some tips and some guidelines. So let's start with, if we come across a problem that says verify that the left side is equal to the right side. That doesn't mean that we can assume that this equal sign is true. So we can't do a lot of the same algebraic maneuvers that we've been used to solving equations with. In other words, we can't subtract 1 from both sides to bring this thing over. You can't do that. And the reason we can't do that is because we're trying to verify that this is true, that this equals this. So since we don't really know that this is true, we can't just go ahead and start moving things across the equal sign. So we have to kind of come up with different ways to do this verification. And it's going to involve these guidelines. Right? So we're going to work with one side of the equation at a time. Generally, you're going to want to start with the more complicated side first. And your goal is to change this more complicated side to be exactly the same as the other side. So we're going to try to come up with some sort of way mathematically to get this left-hand side to be 1. So that's kind of our goal. Number 2, look for opportunities to simplify using algebra. You're going to notice that a lot of these verifications involve a ton of algebra. Skills that maybe you haven't seen in a couple years. Factoring, adding fractions with unlike denominators, getting like denominators, squaring binomials, distributive property, creating a monomial denominator, all sorts of crazy stuff, difference of squares, difference of cubes, all kinds of stuff. So there's going to be a lot of algebra involved. If you're not so good at algebra, this is probably going to be a bit of a struggle for you. Number 3, look for opportunities to use the fundamental identities. The reciprocal identities should come first in your mind. Pythagorean identities should come second, and then odd-even identities, and then all the other crazier ones. We'll use some cofunction stuff in this series. We'll use maybe some double angles, maybe even some power reducing half angles, all sorts of crazy stuff. But 9 identities out of 10 will probably be simplified using these two identities, reciprocal and Pythagorean, along with a ton of algebra. Number 4, when all else seems to fail, if you kind of get really, really stuck, just try to convert everything to sines and cosines. As you know, tangent is sine over cosine. Cotangent is 1 over tangent, which means it's cosine over sine. So everything, even cosecant and secant, obviously can be turned into sines and cosines. And last but not least, always do something. Right? Never give up. Use a pencil so you can erase anything that doesn't work, but always do something. So here I have a sort of a basic list of the most popular identities. Now this clearly is not a comprehensive list. There's a lot more to this, but for our purposes today, I'm just going to basically for the next maybe 6 or 7 identities that we're going to verify, we're really going to try to get by with using all of these and a lot of algebra. So I'll keep kind of going back to this slide so we can look at it just to remember what these identities sort of are. So let's get to it. Let's go and try to verify this first one. Let's verify that the secant of an angle times, there's a multiplication there, the cosine of an angle is equal to 1. Well, if you think about this, the secant is 1 over a cosine. So I can change secant to 1 over cosine. Times cosine is equal to 1. I'm going to work vertically. I'm going to try to keep my equal signs aligned so it's easier for me to stay organized. So if I multiply these two together, right, I get cosine theta. This kind of goes up into the numerator, divided by cosine theta is equal to 1. Well, that's pretty obvious. I think that's easy to see that cosine over cosine is 1. So we're done. 1 equals 1, and we're finished. We have changed the left-hand side to equal the right-hand side. I took a look at the two different sides, and I determined that this one is more complicated, and I made it into one using just a reciprocal identity right here. Number 2. So we're trying to get this whole left-hand side to be cosecant theta. All right, I would definitely say that this is the more complicated side, so I'm going to start there. And I'm going to bring this down. I notice that I have a cotangent. Well, cotangent is the reciprocal of tangent. Tangent sine over cosine, so this must be cosine over sine. All right, cotangent of an angle is 1 over tangent. But I know that tangent is sine over cosine. So that means cotangent must be cosine over sine. Just kind of flip these up. Alright, so we have sine of theta plus, now I just need to multiply these two together. There's multiplication there. So this cosine is going to go in the top to give me cosine squared theta over sine theta. Alright, a cosine times a cosine is cosine squared. But the convention in trigonometry, for some reason, I guess it's just easier to see that this just looks better than writing this every time. So we'll use that notation. Right? Those two things are the same. And let's see. Here I want to keep bringing this right-hand side down. And here I have two fractions that do not have the same denominators. This denominator is 1. And this denominator is sine. So if I get both denominators to be the same, I would have to multiply this by sine. When I multiply that by sine, I get sine squared. So sine squared theta over sine, that's equal to sine. If you were to simplify that out, and I write this, and the reason I did that is so I can have common denominators. Now I can add these two numerators together. Sine squared theta plus cosine squared theta all over that denominator. So I just rewrite the denominator. There's some algebra there for you. And let's see, now I have, do I have anything? Oh yeah, here, look at this. This is cool. Sine squared theta plus cosine squared theta. If I go back to my Pythagorean identities down here, I see that that is equal to 1. I just talked about that in my previous video. So I can change that whole numerator to just 1. So 1 over sine of theta, does that equal cosecant of theta? Yeah, it does. That's the reciprocal identity. All right, that's the reciprocal identity. Cosecant is 1 over sine. Perfect. I'm done. I got my much more complicated left-hand side to be equal to my right-hand side. Try this one. So here I would say that my left-hand side is more complicated. I'm going to change that to equal my right-hand side. Now sometimes these things can take you, 4 or 5 steps. Sometimes they can take 2 steps. I've done proofs that take 20 steps. It's, as long as you get down to the right answer, you're totally fine. So as you go along, you might be getting these verifications proved in quite a different way, and that's totally fine. There are definitely more than one way to do these. So I might look at this thing as a single denominator, or even though they're multiplied together, it's still a single term. And above it are 2 different monomials subtracted. So one of my rules of algebra is that whenever I have sort of a polynomial on top and a monomial on bottom, I can split them up. So I can take that denominator and sort of write it underneath both numerators. There's a little algebra trick for you. Just make 2 copies of it and split it up. I'm trying to get that to equal cosecant squared x minus secant squared x. Alright, so let's see. Cotangent I know is cosine over sine. All over sine of x cosine of x. Minus tangent, by definition, is sine over cosine. All over sine of x cosine of x. I'm trying to get that to be cosecant squared minus secant squared. Okay, so I've got some algebra to do here. I split these up for a reason, so I definitely don't want to combine them back together. I want to keep them separate. And what I'm going to do is say, okay, if I have a fraction divided by this thing, what that actually is multiplying by the reciprocal of this. So I'm going to multiply by the reciprocal of that. Dividing by something is the same as multiplying by its reciprocal. Same thing over here. Sine of x cosine of x, that's my numerator, times 1 over my denominator. Alright, and the reason I did that is now it's pretty easy for me to see that I can just multiply across the top and across the bottom. Sine x times sine x is sine squared x cosine x. Across the top over here I get sine of x. Across the bottom I get, let's see, sine of x, and then there are 2 cosines. Okay, I'm almost done. And this is nice, I can just simplify those. Those cancel out, and the sines cancel out, so that leaves me with 1 over sine squared x minus 1 over cosine squared x. And I'm bringing my right hand side down every time. Just reminds me what I need to get it equal to. So 1 over sine, well, that's cosine, that's cosecant, and there's a squared on the bottom, so we square that as well. This is secant squared. So that's kind of nice. That works out pretty nicely. I'm finished. So there you go, the first 3 trig verifications, starting with a really simple one and working up to a little bit more advanced one. But again, just remember these come back to algebra and your ability to know your basic identities. All right, and these guidelines are really important. If you didn't write these down, now would be a really good time to pause it and write them down. All right, so that concludes part 1. I'm going to record parts 2 and 3 later today. So thanks for watching.